Hey there everyone, nice to see you. Let's talk today about some kind of puzzle or mystery about the turbofan engine of Boeing 737, actually not only of that one, of many of that kind. And looks like everything is working kind of properly every time the plane flies. And the physics behind this is pretty, maybe not simple, but kind of well knitted already through the decades, but something still doesn't make sense. Let's try to investigate the not the burning process itself, but the propulsion process. Okay, so we have this reaction propulsion where the impulse, okay, the force impulse, the propulsion force impulse, is basically created by the reaction gases, which are kind of pushed backwards, okay, and they have certain velocity, kind of high velocity, kind of high speed, and also we should consider what kind of mass is being pushed away, yeah, thrown away. Well, that should be pretty simple in calculation, and the numbers we get may shock you, okay? So let's go into details. Well, the force impulse, the propulsion force impulse, F times delta T, okay, should equal to the momentum of the reaction gases which are thrown back away, okay, from the engine. And this would be delta M times V, okay, delta MV. Well then, if I want to figure out how much mass, actually the main question of today is how much mass is thrown every second, okay, thrown to the back, okay, every second. So if we have thrust of 55 kilonewton per engine, we have two engines, total thrust is 110,000 newtons, okay, then we could simply calculate the number of delta M, okay? Let's do that. Delta M should equal F delta T over the speed of reaction gases. Let's say delta T is every second, so we want to find the spent of fuel also per second. So this would be delta M. And in this case, I would just put 110,000, okay, newtons of thrust divided by the speed. I didn't get accurate numbers. Probably the process is pretty complex there, and the estimated rounded numbers do not make really much sense for the specialists, for the professionals, but it's somewhat around the speed of sound, let's say, okay? It could be a bit more, it could be a bit less. It wouldn't make things dramatically changed if we change something there, okay? Let's say it's 300 meters per second. If you divide these two numbers, you get insane figure. Delta M supposed to be 367 kilograms kilo per second. So every second is, wait a minute, how comes, yeah? Is that really true? Do we really spend so much fuel per second? Do we really burn that much? Kind of almost 400 kilo. But then what kind of fuel tanks do we have? Actually, fuel tanks contain somewhat around maybe 20 tons, okay? But then if it's 20 tons, it won't be enough for that kind of long flight, yeah? The flight would long just minutes, not hours. So what's wrong? Actually, the numbers about the thrust and the speed of the gases is pretty much correct. The formula is also correct. but probably something isn't yet in our radars, okay? So I want just to puzzle you with this video. If you would think of it, consult with the teachers and friends, and or maybe you know already. So you could leave comments below the video. I'll be happy to see them. And next time we will talk about this thing. We'll get more into details of the whole process. Basically, numbers are somewhat accurate. Maybe not totally precise, but somewhat accurate. It's somewhat about this kind of math. But then what's going on? How to interpret this kind of stuff, okay? Let's talk about it next time. With this, I want to finalize this video, okay? If you like it, if you like this kind of puzzle videos with the raw physics in them, please give it a rate. And again, I invite you to leave your comments below. If you want to dig into some other problems with the help of physics and physical science or math, please also share your ideas. We'll talk about it later on. And I want for now just to finalize and to wish you all kind of success in your studies, in your future studies. So see you and bye.